Now let's talk a little bit more about atoms themselves. So this will be, hopefully some of this will be a review of some terms you've heard, but we'll make sure we have some specific details. We want to make sure we're all in agreement on these. Again, get my pointer back. There we go. So an atom contains most of the mass and all of its positive charge in its center, in a small core called the nucleus. So when we're talking atoms, there will be a part in the middle, which is going to be the nucleus. So the nucleus is going to have almost all the mass and all the positive charge. So the nucleus is going to be in the center of our atom. And our atom is going to be our building block that makes up everything else we talk about in chemistry. This is going to be the simplest thing that we can get something that's made out of matter into, is that a single atom that is part of our system. So the particles on the inside of the nucleus that have positive charge are going to be called protons. In addition to those protons, the nucleus is going to contain some neutral subatomic particles called neutrons. So let's say I was working with a nucleus that had 2 protons and then 2 neutral things, we're going to call them neutrons. So we're going to represent plus signs for our protons, and you'll see different things for neutrons. I'll just use an N. So we may have a couple of different particles. So our nucleus in the middle can have multiple particles. It's not just one thing, but it's all mashed together in the center of our atom. So around this, most of the volume is going to be empty space. So an atom isn't just a nucleus. There's a whole bunch of empty space around it. But there are going to be some negatively charged particles called electrons located outside the nucleus. So an atom is going to be electrically neutral, so it's going to have an equal number of these positive particles and negative particles, so that the charges balance out. So in our example here, where we have 2 positives and then 2 neutrons, I need more space for this. We're just going to clear out all the ink for a second. And let's make some more space. So we're going to have 2 protons and 2 neutrons. And then going around it out here, we're going to have 2 tiny electrons that have negative charges. Okay, I'm not as good as a textbook at this. I would like to try to draw the negative inside of these little circles, but I can't fit it. So there are 2 little negatives floating around there. So yeah. So we have to have an equal number of electrons versus protons when we have an atom. Now, there will be types of matter where they're not equal. That'll have a different name, though. It won't be an atom anymore. And we'll cover that in just a second. But these are going to be flying around the atom. And then later, we'll sometimes get more electrons, so they won't. So if we've got our nucleus, let's say we've got a bunch of protons. I'm not trying to draw each individually. Sometimes you're going to have multiple of these rings of electrons. So you'll have a few down here, and then a few more further away, maybe. Maybe we have 6 of each. So you may have seen pictures like this before, and we're going to have a whole chapter where we go into these into more detail soon. But for now, just know that the electrons are going to be flying around the centralized nucleus. And that this can't really be drawn to scale, or the electrons would be itty-bitty specks smaller than a single pixel on your, whatever you're watching this on, like cell phone or computer screen. The electrons are so much smaller when we think about them. So this isn't drawn to scale. There's a whole lot of space between the nucleus and the electrons. It just doesn't have anything. Let's clear this out now for the rest of the notes now. So, of these 3 types of particles, the number of protons is the most essential for understanding what we call the chemical identity of an atom. All atoms with the same number of protons will have the same identity, even if there are differences in the number of neutrons and electrons. So if I have a sodium atom, and sodium is going to have, let me check and make sure. I know this really well, but yeah, it's going to have 11 protons. It's the type of thing I'd use all the time, but I figure if I say it on a video, I'll have messed up and then someone will be confused because I said the wrong number. So yes, sodium has 11 protons. No matter if you have sodium, you could change the number of neutrons it has. Like let's say one of our sodium atoms had 10 neutrons. If you change it to 11 neutrons, it's still sodium. 12 neutrons, it's still sodium. 13 neutrons, it's still sodium. But if you change it to 10 protons, well, now it's neon. It's not sodium anymore. You change it to 12 protons, now it's magnesium. But if you change the electrons, it still stays sodium. So it's the proton number that tells us what type of atom we have in its behavior. If we change the number of protons through like a nuclear reaction, now it's a different atom. Because of this, the number of protons in an atom is given the name the atomic number, which is represented with the symbol Z. So how are atoms going to be different from each other? So we said that all atoms of a single type must have the same number of protons. So again, if we change the number of protons, it becomes a new atom. This is really important to get stuck in your head. This isn't true for neutrons. They can vary. So let's take an example of this. Let's take neon. Neon always has 10 protons. Naturally, it can occur containing either 10, 11, or 12 neutrons. All three of these species of neon are still categorized as neon, even though their numbers of neutrons change. Atoms that have the same number of protons but a different number of neutrons are called isotopes. So how do we represent these isotopes if we want to talk about atoms that are both neon but they have different numbers of neutrons? How are we going to write that to tell other people? So we need something called the mass number. This is given the symbol A, and it's just equal to the number of protons plus the number of neutrons. So we can write this in two ways. You can either write it in this symbology here, where you put the mass number up top. Here's the atomic number, and X is just our symbol. Sorry, chemical symbol. So for example, neon is represented with neon, and so both of these, that would be what X is. And then it depends on the number of neutrons will help us determine what the mass number is going to be. So let's look at some examples of that. So for neon, we said it could have either 10, 11, or 12 neutrons. So if we do that with 12 neutrons, which I'm just going to represent in from now on, I didn't need to write the whole word. So if we have 12 neutrons, all neon has 10 protons, so 12 plus 10 is 22. So that would give us this number up here of 22. In the 11 neutron case, we have 11 plus 10, that gives us 21. And then in the 10 neutron case, 10 plus 10 gives us 20. So neon, 22, 21, or 20. We can also write it like this. Since all neon is known to have 10 protons, it's not necessary to have that number on the bottom left. So we can just write Ne22, and that represents it just fine. Also note, sometimes you're going to see it written like this, Ne22, Ne21, and Ne20, where we don't write the Z that's at the bottom because it's understood as the atomic number, because we know neon means that doesn't have to be written. You'll sometimes see it with and sometimes without. Both are correct, and you should recognize both. Oh, let me clear that part of my ink out. There we go. So for our 10 neutrons, there are 20 total particles, so 10 plus 10 is 20. For 11, 11 plus 10 is 21. And for 12, 12 plus 10 is 22. That's where I got those numbers from. Now, we said how neutrons could change. Let's look at how ions could change. So, it's also possible to change our atom by adding or removing an electron. Since the number of protons isn't changing, it's still going to be the same atom because the atomic number isn't different. So an atom gains or loses an electron, it becomes an ion. So if an atom loses electrons, it becomes a cation. This is because it lost a negative, so it became positive. And something some of my students I know have liked in the past, the cation has the T in it, so the cation includes a plus. So the cation is the positive one. So when you lose electrons, you become positively charged, and you're a cation. When atoms gain electrons, they're gaining a negative, they're going to become negatively charged. And those are called anions. So for example, sodium as an atom, it has 11 protons and 11 electrons. If it loses an electron, this 11 would go to 10. And what we would do is we would write it became positively charged. So we would write it as Na plus, because this plus represents the fact that there is a +1 charge on it. On the other hand, let's take oxygen. Oxygen has 8 protons and 8 electrons. If it gained 2, it's going to have 10 electrons. That was a really poor negative. There's a negative on that E. So 8 plus 2 moves it to 10 electrons. Since it has 2 more electrons than it has protons, it has a 2 minus charge. So we would write it as O 2 minus. Since it has multiple charges, we have to write a number. In the sodium example, there was only one charge. We don't have to write plus 1. We just write plus, and it's understood as being plus 1. Such as if you had something that was a minus, then it would be just minus. So you wouldn't have to put, it would be understood as minus 1. But here, oxygen gained 2 electrons, so we have to represent a 2 minus here. So now let's look at some examples. So how many protons, neutrons, and electrons does chlorine 35 have? So this is the way I can help ask you to solve problems. Now there's one more step I have to show you before you can actually solve this question, is how do I know how many protons I have? Well, it comes from the symbols. So if you look on your periodic table in your textbook or one on Google, and you look up, for example, you'll see chlorine, and you're going to look it up, and let me open up my textbook real quick, and it will have some information on it. It will say 17 up here, and then down below, it says 35.45, and it might have the word chlorine underneath the CL. Now for right now, we're going to ignore this bottom number for now. It's going to actually be your most used number on the periodic table, but we're going to get to that in a few slides. What's important is this number up top, the whole number, this is the atomic number, which represents our number of protons. So anytime you have a symbol for your atom, it's a way of telling you how many protons there are. So for this problem, we know that the protons are equal to 17 because it's chlorine. Now, let's get neutrons next. This number here, remember, is our mass number. Mass number is equal to our protons plus our neutrons. Therefore, if 35 equals 17 plus our neutrons, we subtract 17 from both sides, and we'll get that there are 18 neutrons in chlorine 35. Now our electrons, you'll notice there's no charge on this. Right here, that means it's neutral. So protons and electrons are equal. They're both 17. Another way we could ask the question, what is the symbol for an atom with 22 protons? So here you would go to your periodic table and look to find where you can find the number 22 at the top. So you'll notice as you go left to right, the numbers go up. And then if you get to the end, you can start a new line and it'll keep going up. So I go all the way to 22 and I get the symbol Ti for titanium. So that would be my symbol for that. It didn't tell me anything about the neutrons, so all I can give it is the symbol titanium. Now, a third way, another example of how we can ask these questions, is how would you write the symbol for a sodium atom that has 12 neutrons and 10 electrons? So we know it has 12 neutrons. That was poorly written. So we're going to try this again. So 12 neutrons, 10 electrons. So sodium, if we look for it, we can find it. Sodium has the symbol Na. And Na has 11 protons. So the symbol would be Na. The number in the top left is going to be our protons plus our neutrons. So 11 plus 12. That'll be 23. Then we did compare the protons to the electrons. Notice there's one more proton than there is electrons. So that means it's going to have a +1 charge. So I'm going to put a plus right here. And so this is an answer that would be acceptable. You also could have written 23 Na plus, and you could have put an 11 down here for the atomic number. Both of these answers would be correct and fine for doing this. So these are just examples of different ways we can ask you about those last couple slides pieces of information. How do we know about the different subatomic particles that our atoms are made of? And how can we ask that question and represent it with in different ways?